Hello learner, welcome to Manifested e-learning platform. We are going to proceed learning about a topic heading reflection and congruency. In our last lessons, we looked at symmetry lines of a rectangle and a square. But today our lesson will be centered on symmetry lines of triangles. So in each and every lesson, we'll always have an objective. The objective of the lesson is to enable the learner identify angles, triangles that have symmetry lines and those ones that don't have symmetry lines. So it is for us to identify that. So here I have a series of triangles. We have the first triangle whose all sides are equal. This one is referred to as an equilateral triangle. We have another triangle where one pair of the sides is equal. That one is isosceles triangle. And we have the other pair, the other two, where none of the sides is equal. For this one, each side has its own length. And even this one, you'll find none of the sides is equal to each other. So we shall start with the equilateral triangle. And in our first lesson, we learned that symmetry is the proportionate similarity between two halves of an object. So this is the equilateral triangle. Let's get two halves. Let's get two halves. I can fold it like that. Fold it like that. It will give you two halves. That is one line of symmetry. I can also fold it like that. Fold it like that. That will give another line of symmetry. There is a last method I can fold it that way. You'll get another line of symmetry. And in fact, the lines have already traced themselves out on the paper. So an equilateral triangle will have three symmetrical lines of symmetry. We'll move to the second one. This is an isosceles triangle. For those who don't know, a pair of the sides are equal. A pair of the sides are equal. Let's try to get it into two halves. Let's start with folding it along the side that is non-equal to the others. So I fold. So I get my two halves. I'll get my two halves. That's one line of symmetry. I'll try the others to see whether I can get. Fold at the center. So if I fold at the center with the other one, it is difficult for me to get two halves because there is an extra area below there. If I try the other one, the other non-equal side, I'll still get the same thing. So we eventually realize that an isosceles triangle will only have one line of symmetry, one line that can divide it into two equal parts. I'll move to the last triangles where none of the sides is equal. I'll start with this one. which looks like a right angle. It's a right angle triangle, but none of the sides is equal to each other. Let me fold. I think that will not give me a symmetrical line because this part is not equal to the other one. I'll try the other one. That one can't. So for such a triangle where none of the sides is equal to each other, the triangles do not have a symmetrical line. None of the sides is equal to each other. It is all similar also to such a triangle, which many refer to as a scalene triangle, because when you work the height seems to be, has to be extrapolated from outside. This is a scalene triangle. If I try, I can never get symmetry in any way. So, to summarize that, we shall begin with the equilateral triangle. Note that I just showed that physically, but to get the lines by construction, you should construct the equilateral triangle and bisect all the three sides. So I'll start with the equilateral triangle, any sides. So I'll start with this one. All sides are equal. I'll start with that. From my demonstration, we got three symmetrical lines, but they can ask you to construct them, to show them by construction. So to show them by construction, you'll bisect all the three sides. I'll get the first bisector. Get the first bisector. So try always to check the axe because of the nature of the sliding protractor. So always check whether you use the right axe. There's room always for an error. So check the axe because there is always room for an error. So you draw. Due to the sliding, the axe should almost be at the center. You'll also bisect another pair. I can bisect this one. So join the two. If I bisect the other one, I'll almost get a line joining the same point. So the three bisectors, the three perpendicular bisectors of the sides will give the lines of symmetry. So these are the, you can draw that. These are the lines of symmetry. So you conclude that, learner, you'll conclude that an equilateral triangle has 3 lines of symmetry. That was a equilateral triangle. The other triangle I demonstrated was the isosceles triangle. And from the demonstration, it only had 1 line of symmetry. So I can show it. They can ask you, you do it by construction. So do it to any length. Use any length, but make sure that one side is, the 2 shorter sides don't equal the longer side. So choose a distance slightly bigger than, choose these. Come and choose that. Join. So that is isosceles. This side is equal to that. So we realize it only has 1 line of symmetry passing through the center where the 2 equal sides meet. So it has 1 line of symmetry there. So they can tell you, you show the line of symmetry by construction. So to show the line of symmetry by construction, learner, you bisect this side, this longer side, then an equal side. You bisect it. So on doing that, you'll get the line of symmetry. And the conclusion is an isosceles triangle has 1 line of symmetry. So we move to the last 2 triangles where none of the sides are equal. So that is B. When we move to C, learner, we are talking about triangles that none of the sides is equal to each other. Triangles so we can have such triangles, learner, where none of the sides is equal to each other. Such triangles, you can never get a symmetry line. So such triangles do not have any line of symmetry. So in conclusion, we say that we've looked at those 3 types of triangles. Learner, we looked at the isosceles, the equilateral triangle, it had 3 lines of symmetry. We looked at isosceles, which had how many lines of symmetry? 1 line of symmetry. In most cases, we call such a triangle a scalene triangle. Note that a scalene triangle can also be isosceles if a pair of the sides is equal. A pair of the sides is equal. So note this one can also have a line of symmetry only if 2 sides are equal. So in conclusion, equilateral, 3 lines of symmetry, isosceles, 1 line of symmetry, and lastly, any other triangle you'll find with none of the sides equal to each other, it will have no line of symmetry. It will have no line of symmetry. So to conclude, make sure that you get the objective in the lesson. You can identify this is isosceles, equilateral, not equilateral, not isosceles. It will mean it is the other triangle. So at that point, I'll give you a short assignment, which will sharpen you on getting the few concepts learned there. So for the assignment, so you'll work out that just to effectively put in what we've gone through in the lesson. So at that point, I wish you the best in getting the solution to that, and have a nice time before we meet in the next lesson. So thank you and bye.